Now let's start with optimization theory. This is a word that we use in our daily language. Right? We try to optimize something. We try to optimize our time, our holiday schedule, our work schedule. And if you think about it, in an optimization, you have some degree of freedom, which we will mathematically call optimization variables. You have some objectives you want to maximize or minimize. For example, maximize your employability, okay, your happiness, minimize the cost it takes to finish some task. And then you have some constraints. Without constraints, the problem would be too good to be true. This could be constraints on the time you have, on the money you have, on the energy you have. For example, when you look at your schedule this weekend, you may say, well, I can pick my variable to be spend the time taking a course like this one, or spend the time to watch a movie. And the objective function may be, well, make me as happy as possible. And the constraints, say, is you only have 24 hours in each day. Now we will see a mathematically precise, unambiguous language called optimization theory. And in each optimization problem, there are four main data fields. One is, of course, the objective. Now, in the case of transmit power control in cellular networks, the objective is to minimize the sum of the individual transmit powers. So we'll write minimize the sum of the PIs over Is. So this is a power minimal configuration, subject to the constraints that you have to achieve the target SIRs for all the users. The SIRs for each user indexed by I must be no smaller than the target gamma I. And you need this to be held not just for a single I, but for all I's. And then you need to vary the degree of freedom. In this case, obviously, it is the set of transmit powers. And everything else are constants, including the channel condition, the GIJs, the noises, NI for each receiver, and the target SIRs, gamma. Towards the end of this lecture, we'll also see what would happen if these target SIR values become variables as well. But for now, they are held constant. Now, once you have an objective function, a set of constraints, and you know what is variable and what is constant, then you have an optimization problem.